the few announcements there are. We are now recording, so let's get the slide open. I think I announced last time, but if I didn't, here it is now. The Alabama State Department of Education has teamed up with Alabama Possible to host college application something or other. They cut off part of this free application week, and that's been this week. Now, not all schools are doing it. Perhaps Sanford Long is a private school, and not all the public schools are doing it. Now, of course, two-year colleges never have an application fee, so there's not a requirement there. But anyway, this has been waived this week, so if you know of anyone who was, either you yourself or someone else who was planning to apply to a college or university in Alabama, you can check and see. In fact, here's the list of them. Alabama A&M, Alabama State, Auburn, AUM, Fortis College, Huntington College, Jacksonville State University, Judson College, Marion Military Institute, Miles, Selma University, Spring Hill College, Stillman College, Talladega College, University of Alabama, Troy University, Tuskegee University, and then there's one that I can't read. It's not University of Montevallo. I can read that one, but it's University of M.O. Is there a Mobile? University of Mobile? Okay, that must be it. University of South Alabama, which is in Mobile, and University of West Alabama. So anyway, Doug Jones said this, our Senator Doug Jones, who's running again, so be sure you participate in the election. It's an honor and a privilege. Okay, and if you need to talk with someone here on campus, this Akili M. Haley is our career and college transfer services coordinator, quite a title. She has an office on this campus, but also on the Birmingham campus. I didn't see her. I don't know if I went by our office today, but I don't recall seeing her. Jacksonville State also followed this up. Their Alabama's College Application Week. They're waiving the $35 application fee this week. November 4th, that was Monday through 8th, which is tomorrow. So this ends for them tomorrow. So I have the information on that if you want. By the way, you got these emails as well as I did, so check your emails. They're there. And University of Alabama, their free application week actually goes till 11:59 Sunday evening. So theirs goes from the 4th through the 10th, which is a full week, minus 1 minute, 11:59 Central Time on Sunday the 10th. Oh, wait. Yeah, that's right. All right, so those are the major announcements there. Now, here are a couple that pertain just to Lawson or to me. First, this afternoon, normally I have office hours after this class is over with at 12:45 until 3:15 when my second mini-term physical science class starts. However, today we have a faculty meeting right across the parking lot here in the Ethel Hall building. So I will have to leave here a little before 2:30 because the faculty meeting starts at 2:30. So I won't be in the office from 2:30 to 3:15, so we'll lose 45 minutes there. But I will come back and teach my 3:15 class, okay? I'm not staying for the whole meeting. I'll just go to what I can. Now, normally on Fridays, I have office hours on the Birmingham campus, 8 to 12. I'm supposed to be going out of town tomorrow, so I put in for that leave. But if I wake up tomorrow feeling like I did this morning when I woke up, I'm not going to campus for sick leave. I mean, I'm going to take sick leave for it because if I didn't have classes today, I'd have been home in bed. And so anyway, so that's tomorrow. Monday, of course, you know, bad news, good news situation. You know that one, right? Yeah, we don't have, college is closed for Veterans Day. All right, another thing happening next week. I think I told you about the SACS visit, did I? Our accrediting agency. They're going to be on campus next week, probably at least Tuesday and Wednesday. What's that? Yeah, accredit the college. So we'll be, if you see anyone, they're going to be mostly, I'm sure, on the Birmingham campus. But I know some will come out here because they'll check the library and check a few other things, I'm sure. So mostly they'll be on Birmingham. But if you do see them, be kind to them. Okay? And nice. So most of the heavy lifting's already done. The paperwork has been being worked on for years now, and that was all submitted. They just come to campus to make a visit, to make sure we are doing what we said in the paperwork we were doing. All right. That's all I can think of. The rest of it will be Thanksgiving stuff. I'll wait another week or two to do that. All right, so we're in Chapter 3, Determinants, 3.4 Applications of Determinants, and maybe today we'll finish this. But the way my voice is, I'm not sure what I'm going to do. In addition to what we did last time, which was Kramer's rule, which is a use of determinants, here we have another. This is determining area, volume, and equations of lines and planes. Okay? Now we're going to do them in a slightly different order than that. We'll do area first, then equations of lines, then volumes, and then equations of planes. But, same thing. So what if we have a triangle? Okay? And all we know about the triangle are its three vertices. Okay, let me get my pen set up. All right, you have x1, y1, and x2, y2, and an x3, y3. Okay, now, most of the time, any three random points you pick will form a triangle, the vertices of a triangle. However, if you just happen to get two of these or all three of these on the same line, that's not going to form a triangle. So at least one of them has to be off a line with the other two, okay, to make a triangle. So as long as that's the case, the area of that triangle, believe it or not, of course you might think of area of a triangle would be 1/2 base times the height. Well, you'd have to have the base drawn out, calculate the distance, the distance formula, then somehow find the perpendicular distance, which you can do, and then find that height, multiply by 1/2. Sort of tough. Determinants actually can make it pretty easy. Okay? The area is defined to be plus or minus. Okay? Now you might say, wait, why plus or minus? Okay, get to it in a second. 1/2, well, that was in the first formula too. Okay? But then the determinant of this matrix, x1, y1, 1, x2, y2, 1, and x3, y3, 1. The determinant of that matrix. Now, why plus or minus? Well, that determinant could be positive or negative. Areas are always positive. So if that determinant turns out being negative, use the minus sign, make it positive. If it turns out being positive, use the positive sign, keep it positive. Okay, So it's 1/2 that determinant. Now that column of ones, I can't answer why it is, but it just works that way. Okay? That is your area of any triangle as long as these 3 points are not on the same line. Okay. Now they do a really nice job of proving this, and I don't want to do all the proof, but I do want to show you the basics of it. Let's just assume that your 3 points are in the first quadrant. They don't have to be. They could be anywhere. They work anywhere. But we'll just use it in the first quadrant. And let's just say we have a point there, and a point there. Okay? That's your triangle. Oops. I should be able to draw straighter lines in this, but there's your triangle. Now, here's your construction lines. Let's drop a value down here. Let's just call this one, I think that's usually x1. Yeah, we'll call this one x1, y1. That point right there. So this is x1 here. Okay? And this is y1 here. Let's see. They did this one over here to be your x2, y2. And this would then be x2. And this would be y2. This point up here they identified as x3, y3. So this is your x3, and this is your y3. Okay. Now, what we're interested in, and I think I'll go to a different thing. I'm going to go to gold, sort of a highlighter. And what we're interested in is the area inside here, right? That's the area of the triangle. Okay. What we're going to do is, I'm going to use a different color, but still sort of light. We're going to do the area inside 3 trapezoids. Okay? Here's a trapezoid here, from here to here. Those 2 lines are parallel, and these are not. So this is a trapezoid here. The area, I should have picked a different color. That's the area in that trapezoid, right? Okay. Then, let me pick a different color. You want to pick the color? Second? Red. Okay. All right. Then we'll do the area in this trapezoid from here to there, and that would be that trapezoid. Okay? So there's 2 trapezoids, and we've covered the entire area of the triangle plus some, right? Well, let's do one more trapezoid. You want to pick another color? Green? How about that light green there? Let's do this trapezoid from here to there, and that's this one. So if you subtract that off from the sum of the other 2, you've got the area of the triangle, right? So it's a pretty clever way of doing that. Now, you have to remember what the area of the trapezoid is. I don't know if you remember that one. If you take, let's say, what's that?
I just remember it being kind of similar to the triangle.
Yeah, okay. Let's take this red trapezoid here. That's the big one. Okay? I want you to mentally do this. Flip it over and reverse it. So this short side goes on top here, and this long side goes on top there. Okay? What that will form is a rectangle. So let me, this will not be pretty, and it will not be very accurate, but let me do the best I can. Pick me another color. Purple. Okay. So what I'm going to do is take this red trapezoid and put the short side here, the long side here, and that will come across here, and this area here is exactly the red area. Isn't it? You flipped it over, same side, you just flipped it and reversed it. Okay? Well, that forms the rectangle, a perfect rectangle. So what is the area of that rectangle? The width, x2 minus x3, times the height, which is y3 plus y2. See y3 here, y2 there, because this is y2. Okay. So it's y3 plus y2 by x2 minus x3. Okay? And half of that. Well, this trapezoid will be half of this. This trapezoid will be half of this. So that's where the 1/2 comes from. Okay? Now, if you did all those coordinates I just said, the subtractions and the multiplications and stuff, it winds up being exactly the same ones as you did in the determinant. Amazing but true. But yeah, it does turn out. You can do the one they do in the book, and it shows indeed there the other side. But rather than do that, let's actually do one. Okay? All right, for me to erase? Okay. Find the area of the triangle whose vertices are, let me go back to black here, 1, 0, 2, 2, and 4, 3. Hey, okay, there's the 3 vertices of the triangle. And what we have to do is find the area of that triangle. And we don't have to draw any pictures. We don't have to do any areas, trapezoids, or anything else. We can just use the definition. And what is that? Plus or minus 1/2, determinant of 1, 0, 1, 2, 2, 1, and 4, 3, 1. Okay. Now, that's not going to be a bad one to do anyway, but one fairly easy thing you could do to make it just a tad easier is either eliminate, say, a 2 here. I'm sorry, not here. Either eliminate a 1 here. Yeah, eliminate a 2 here or a 3 there. That would give you a column with all the 1 0. Or eliminate either one of those 2 ones. And that would make it just a little easier. How, have you got a preference?
I would do the column operation on column 1 and 3.
Right. And which one you want to eliminate? The one on 1 or the one on 3? I'd sort of like to eliminate this one because I'd like to keep those 3 ones. This is really easy to do. Okay. So let's eliminate this one. So what we're going to do is minus column 3 plus column 1. Right? Okay. And that's not going to change the determinant any. So it's plus or minus 1/2. Okay. And if you do that, minus 1 plus 1 is 0. Minus 1 plus 2 is 1. That makes it easy. And minus 1 plus 4 is 3. And then column 2 stays the same, 0, 2, 3. And column 1 stays the same. Column 3 stays the same. 1, 1, 1. All right. Now, pretty easy to do the determinant of that. What would that be? afraid I'm going to have to go down the hall for just a minute because my cough is picking up and I'm getting all congested. I'll get right back. You want to leave this up there? Yeah. I'll be right back. Turn off or pause the recording. I forgot and left it on. Okay. Bet you have it all worked out by now, don't you?
Yeah, I had it worked out.
Yeah.
Actually, but I think I had to use the other one.
Oh, you did it the other way?
Yeah, I did it. Negative column 1 plus column 3.
I see. You get almost the same thing. It's just negatives on this one. Yeah. Okay. Well, what do we do with this? Well, I suggest let's use that 1, right? Because we're going to eliminate that row and that will eliminate that column as well. What is position sign of that 1 up there? Positive. Okay. So I think we'll see. So it's going to be plus or minus 1/2 of 1, because that's the 1. And then you do the determinant down here, and what do you get? 3 minus what? Second?
3 minus 6.
Which is? Negative 3. All right, so we will need to use the minus sign to make this 3/2. Right? And that should be what it is. Did you get the same thing your way? Okay. They just straight did the determinant with what they had, but they didn't show you how they did it. They just said they got it. So however they did it, they got 3/2 as well. Their determinant wound up being negative, but then we used the minus sign. Well, the determinant wound up being negative 3. The 1/2 made it negative 3/2, and then the minus sign made it that. Now, what if all 3 points had been on the same line? In that case, the 4, 3, 2, 2, and the third point, rather than being 1, 0, happened to be 0, 1. Well, what happens to that determinant? If you had 0, 1, 2, 2, 4, 3, what would that determinant be? The area would then be plus or minus 1/2, and that would then be 0, 1, 1, 2, 2, 1, 4, 3, 1. Okay? What would that one be? Now, there's nothing that reaches out and smacks me on that one to indicate it's going to be an issue. And I would do the same thing except using column 2 to eliminate column 3. No, sorry, the other way. 3 to eliminate the 1 and 2. So minus column 3 plus column 2 would be plus or minus 1/2, 0 to 4, and minus 3 plus 2 would be 0, 1, and 2, and then a 1, 1, 1 here. And now I do see a problem, don't you? No, not yet. Well, let's see. All right. Again, use this position. So it's plus or minus 1/2. And that's going to be a positive 1 still. What do you get here? It's what? 0. Yeah. So that's what happens if the 3 points are collinear. So you don't have to worry about them. That'll give you a 0 area, which indeed it is. That triangle is a flat triangle. There's no area to it. All 3 points are in the same line. If one of these was a little off of that, yep, you're going to have an area. Okay. Now, well, guess what then? We've just developed a way to tell if 3 points are collinear. Because, yeah, I can sort of look at those and tell they are. The difference of this is 2, the difference of that's 1, the difference of that 2, the difference of that 1. Yeah, they have the same slope. Rise, run, you know, it's going to be the same. But without doing that, I could just do this. Set the if I did the determinant and wound up being 0, you know they're collinear. Which you could also, if you only knew 2 points and you wanted a third point that is collinear, set it equal to that. So that's a little more far-fetched. But this is, so let me basically say the same thing we said, but let me write it out. All right, to erase. Okay. Test for collinear points of the XY plane. If you have 3 points, X1, Y1, X2, Y2, X3, Y3, they are collinear if and only if, I use that symbol because it's easier to write than all those words, the determinant of X1, Y1, 1, X2, Y2, 1, X3, Y3, 1, if that determinant is equal to 0. If they're not, it's not, okay? So that's your test for collinear. So guess what? We can use that for another purpose. What if you're given 2 points in the XY plane? Can you find an equation for a line passing through the 2 points? Okay? And the answer is yes, you can. It's just you take one of these points and put just XY. Okay? and then rearrange the order they usually do. You don't have to, but here's what that would give you. I'm going to start over. Well, probably shouldn't have erased those. Let me do over down here. So I'm going to put that back in. I'll just write it down here. An equation of a line passing through two distinct points, x1, y1, and x2, y2. Well, we know how to get that equation, don't we? All you need is a slope and a point, and you got, so you first have to calculate a slope, y2 minus y1 over x2 minus x1, or vice versa, whatever you do. Okay, that gives you the slope, and then you do x minus 1 or 2, it doesn't matter which, x minus x1, y minus y1 is equal to that slope you just calculated times x minus x1. That's the point slope formula. But guess what? This does it just as well, and I think a little easier. So that gives you the equation of a line through these points. Let me write this out. The equation of the line between these 2 points, okay, is given this way. The determinant, here you just put the first column, your variable x, y, 1. Then do your x1, y1, 1, and your x2, y2, 1. And do the determinant. You don't have to do a half, you don't have to do anything else, just do that. Okay? Now this, don't be eliminating, just do the determinant. So what I think I'll do, since it's a 3 by 3, let's just drop that determinant bar there. And repeat the first 2 columns, xy, x1, y1, and x2, y2. Okay, and then do our diagonals. First down diagonal says y1, or xy1 plus, I'm going to do it y1x. I like it that way better. Okay, sorry. I'm going to do it the way I read it, but let's do it the other way. y1x plus x2y. Yeah. Third diagonal is plus x1, y1. That's just a constant x1, y2. That's just a constant, by the way, right? Because those are just numbers, okay? Now I'm going to erase my construction lines just to make it easier to read. And do my up diagonals. Minus x2, y1 minus y2x minus x1y. Okay, add these together. y2 minus y1 times x plus x2 minus x1 y sort of when I erase things, I left remember that determinant's equal to 0. I left that off, but it's pretty important. So all this is equal to 0. And this is minus just a number, x1, y2. Let's make that a plus, okay? Minus x2, y1 is equal to 0. There's an equation, okay? The problem is you got 2 unknowns and only 1 equation. Well, not really. Let's see what we get. Well, that's what you want. You're looking for an equation of a line, so you need x's and y's in there. You're not solving for it, you're looking for it. And you can proceed like that. They don't take it any further. No reason to. It's so much easier to do with numbers. So let's just go and get the numbers. Do example 6. Find the equation of a line passing through these 2 points. 2, 4, and negative 1, 3. Tell me how to do that. X, Y, 1, 2, 4, 1, negative 1, 3, 1, and set that equal to 0. That will be your equation. Now, I'm going to go back and erase again, like I did before. But just remember, you're setting equal to 0. Repeat the first two, x, y, 2, 4, negative 1, 3. Okay. And what you get? For x minus y plus 6, right? All right. Take out your construction lines just because they get a little messy here. Goodness, my throat is going on me. Let's do our up diagonals, and there'll be a plus 4, right? It's a minus 4, but it's going up, so it's plus. This will be a minus 3x, and this will be a minus 2y, and combine those and you get x minus 3y plus 10 is equal to 0, or x minus 3y is equal to minus 10. Either way you like to write it. There's your equation of a line. Now, that's how they left it too. That was pretty easy to do. Okay? Doing it the other way, what you could do is find the slope first. I'm going to let this first one be my x2, y2. It doesn't really matter. So let's do this. The rise over run would be 1 over 3. So that's your 1/3. That's your slope. Okay? Then we do, pick either point you want. I think I'll choose the second one. You have y minus 3 is equal to 1/3 times x plus 1. So any way you want to do it, I would suggest multiplying everything by 3. 3y minus 9 is equal to x plus 1, and then moving things around to get it to look like theirs. Let's subtract 3y from both sides, and also subtract 1 from both sides, and that gives you, on reverse sides here, x minus 3y is equal to minus 10, which is exactly what we got. But you know, it seemed like to me there were more possibilities for making a sign error or something else doing that than there was with that. Pretty easy way to do it. So there was example 2. All right. Now, formula for an area in a plane is a straightforward generalization to three-dimensional space, which would presented without proof, thank you very much, as follows. The volume of a tetrahedron with 4 vertices, okay? And let's get what that is. I'll do this one without proof. Oh my goodness, my throat hurts. So we have a tetrahedron with 4 vertices. X1, Y1, Z1. Now you're in space, okay? X2, Y2, Z2. X3, Y3, Z3. I can't write. Oh man. My head is just, I feel like someone packed it full of sponge and then sprayed water on it. You know? So, in it, I get my pen back, it's sub 3, and X sub 4, Y sub 4, Z sub 4. All right. So I'm going to put my head down on the desk and go to sleep. Okay. But I can't. All right. So there's 4 points in space. Now, any 3 of these points is going to define a plane, okay? A triangular plane, triangular shaped plane, shaped within a plane. If all 4 of them are in the same plane, then you don't have a tetrahedron. You have a flat plane, okay? So you got to make, well, so what we have, the volume of the tetrahedron is then defined to be plus or minus, same as before, but this time 1 over 6. Now, I'm not going to be able to tell you exactly where the 6 comes from. I can't remember if I've ever thought through the proof of this enough to know, but if I have, I've forgotten it. I don't think I have. 1/6, plus or minus 1/6, the determinant of this 4x4 matrix. Okay? X1, Y1, Z1, 1, X2, Y2, Z2, 1, X3, Y3, Z3, 1, X4, Y4, Z4. I did it again. Goodness gracious. Z4, 1. Okay. That will be your volume. As you may suspect, a 4th dimension going to be a few more operations, quite a few more operations. But if you can use techniques, you can get it done rather nicely. So the plus or minus sign is only there to make sure your volume is positive. If that determinant came out negative, use the minus sign. If the determinant comes out positive, use the plus sign. Okay. So I'm going to erase because we will need probably all the room we could get, and maybe then some. Oh my goodness, I can't breathe. Find the volume of the tetrahedron whose vertices are 0, 4, 1, 4, 0, 0. Thank you very much. That's a nice one. Okay. 3, 5, 2. I can't find my place here. 3, 5, 2. And the 4th point is 2, 2, 5. Okay. Oh man. Another little issue with this is I took some Tylenol before I went to bed, or acetaminophen before I went to bed, and then got up and took another during the night. But then I was so clogged up I couldn't breathe. So I went on and took a Benadryl, which is good about loosening you up, but it knocks me for a loop. So I feel drugged from the Benadryl. Okay, so the volume of this tetrahedron, if these are 9 coplanar points, is plus or minus 1/6 of the determinant. How do you get that determinant? Yeah, 0, 4, 1, 1, 4, 0, 0, 1, 3, 5, 2, 1, and 2, 2, 5, 1. Okay. Now again, you got a choice. You can either do the determinant straightforwardly, which I do not recommend. I would try to eliminate something. You got a row and a column? No. A row and 3 columns with 1 0 in it, but you got a row with 2 zeros in it. Okay? So I'd say let's eliminate one or the other end of that row. Which one would you like to eliminate? Yeah, I'd like to eliminate that 4. Make that a 0. So let's do minus column 4, minus 4 column 4, plus column 1 is going to be the new column 1. Man, shoot me and put me out of my misery here. Plus or minus 1/6. Okay, that won't change the determinant any. That's why we're doing it. And the first entry here would be a minus 4, right? The next entry would become a 0. The next sorry. Sorry. All right. I guess, write that as column 1 minus 4. That's where I'm messing me up. Okay. 3 minus 4 is a minus 1, and 2 minus 4 is a negative 2. Okay. Then the others stay the same. 4, 0, 5, 2, 1, 0, 2, 5, and 1, 1, 1, 1. Okay. It's going to be plus or minus 1/6. Now, question. What is the sign of the position of that 1 over there? We're going to eliminate this row and that column. So what's the sign of that position right there? Say again? Okay. Plus, minus, plus, minus, plus. Absolutely. So it's going to be a plus 1. So that's not going to be too hard. Then you got the determinant of this matrix. Minus 4, 4, 1. And I'm going to go on and expand it out. I'm not going to mess around with eliminating anymore. Minus 4 and 4. Minus 1, 5, 2. Minus 1 and 5. Minus 2, 2, Gracious, this thing drives me sort of nuts. I keep hitting the wrong thing. Minus 2, 2, 5, minus 2, 2. All right. Now let's just do the determinant there. What does that give you? Okay. Plus or minus 1, 6. Don't forget that. I'm going to leave off the 1. That's not going to be important. Okay. Say again. Negative 100. Okay. This one will give us negative 16. And this one will give us negative 2. Now let's get rid of those construction lines and do the up diagonals. What would that give us? Plus 10, isn't it? Okay, because you're going up. Okay. This one will give you plus 16, which that will wipe out the minus 16, and then this will give you plus 20. Okay. So this will be plus or minus 1/6 of negative 100, negative 102, by the way, plus 30. That, I think, will be negative 72, right? I do it right? Okay. So we're going to use the minuses and make that a plus. 6 will go into 72, 12. So what's the volume of that tetrahedron made by those 4 points? Plus 12. Whatever cubic units they were in. And that serves how they got it to. Gracious. I don't know if it's the cold or the medicines I took. Something has my stomach messed up too, so it's roaring up here. Maybe it's just hungry, I don't know, but anyway. Now, as I said before, this works when those 4 points are not in the same plane. But what if one of them, any 3 of them are got to be in the same plane, but what if the 4th one is also in that same plane? Then your determinant, because the volume will flatten out to be 0, your determinant needs to be 0 too. So this is the test for coplanar points in space. Four points. Excuse me. X1, Y1, Z1. X2, Y2, Z2. X3, Y3, Z3. And X4. Did it again? It wasn't on the Z this time, though, the difference. Oh, man. X4, Y4, Z4. These 4 points are coplanar if and only if this determinant, okay, X1, Y1, Z1, 1, X2, Y2, Z2, 1, X3, Y3, Z3, 1, X4, Y4, Z4, 1. I know that it's not written very well. I'm losing it fast. If that determinant is equal to 0. So, if you're given 4 points, take the determinant. If the determinant is 0, then you know they're in the same plane. If the determinant is not 0, do plus or minus 1/6 times it, and you got the volume of the tetrahedron formed by those 4 points. Okay. Now, what if we have, I just said earlier, any 3 points are going to define a plane somehow, triangular plane, triangular region of a plane. As long as those 3 points are collinear, okay. But if they are not collinear, they form a triangle, and that defines a plane. So, how you get a 3-point form for an equation of a plane, and I'm not sure we kind of did something like this in calculus. But here's what you do. If you're given 3 points and you want the equation of the plane that does pass through those 3 distinct points, when it says distinct, that means non-collinear points. Okay? X1, Y1, Z1, X2, Y2, Z2. Left off my 2 that time. And X3, Y3, Z3. To find the equation of the plane that contains those 3 points is just take the determinant of, this time the top, the top row are your variables, X, Y, Z, 1. Just like we did for equations of a line, you have the variables up there, then X1, Y1, Z1, 1, X2, Y2, Z2, 1, and X3, Y3, Z3, 1. And set it equal to 0. Then you'll get the equation of a plane. So let's do that. Oh, I still can. Okay. Here's example 8. Here's 3 points. 0, 1, 0. Okay. Negative 1, 3, 2. Third point, negative 2, 0, 1. Okay. You want to find an equation of a plane that passes through those 3 points. Set up your determinant. What's your top row? X, Y, Z, 1. And then, really, it doesn't matter the order, but put them, just as soon put them in this order. Remember, changing the order only changes the sign. Where you got, it's going to be the same plane, whether you got the plus or minus on whichever side. So 0, 1, 0, 1, negative 1, 3, 2, 1, and negative 2, 0, 1, 1. I'm so sorry I can't get help from yawning because I can't breathe. And we set this equal to 0. Now, this does get messier. Because if you start eliminating a row or something like that, okay, don't do it to the columns. I mean, you can, but then you're subtracting a multiple of z from y or x or something. And it works, but it really gets messy. So if you're going to do an elimination, see if you can do it with the rows not involving the first row. It can be done that way, but I like to avoid that. Now, but I can't see any easy way to do it. I would either like to eliminate the one here or the one there. But you see, doing either one of those is going to mess up your other two zeros. So maybe columns are better, but then not. Yeah. As long as you use the fourth column, because you're not going to mess with the y. I mean, you can still do that, but let's do that. Let's eliminate this one using that. Okay. So we're going to do column 2 minus column 4. Okay? So that's going to be x 0 minus 1 minus 2. Y minus 1, 0 to negative 1. Z, 0 to 1, and 1, 1, 1, 1. All right, this isn't going to be too bad. So we'll choose this to work with, 1 over the n. So that means we're going to eliminate the fourth column and the second row. And again, you've answered the question already, but what is the sign of that position? That's positive, yeah. This is equal to 0, remember that, okay? So the determinant of that is going to be 1, so that's fine. What do we have left? The determinant of, I'm going to start over here, of x, y minus 1, z, minus 1, 2, 2, and, whoops, especially when you have these binomials in there, you have to spread it out a little bit more, okay, and negative 2, negative 1, 1. Okay, now, I'm going to go and expand that to x minus 1 minus 2 and y minus 1 to minus 1. And let's do our down diagonal now. I've gotten a little sloppy here, so my lines aren't too straight. This is equal to 0, by the way. So this produces, say again, 2x. This produces, now this one's a little trickier. What? Minus 4 times y minus 1. I'll go right out this way. We'll fiddle with it later. And this gives us plus z, is that what you said? Yeah. All right. Oh, to be able to breathe again. Yeah, I just lost my y. Okay. That, I think, is a plus z. It's a pretty ugly looking plus. Okay. All right, let's do our up diagonals. What will that give us? plus 4z, right? Plus 4z.
No, I was looking at the first, last
Okay.
yeah, you're right.
That's okay. Then let's do the next up diagonal. What does that give us? Plus 2x. And the last diagonal is going to be a
Plus 5.
no, it's y minus 1, isn't it?
Yeah.
Okay. Plus y minus 1. Okay? And all this is equal to 0. Remember that. Don't forget that part. Okay, so let's see what we got. We got 4x. And this comes out a minus 3 times y minus 1 plus 5z is equal to 0. So, expanding that a little bit, 4x minus 3y plus 5z plus 3 is equal to 0. Okay? Or you could say 4x minus 3y plus 5z is equal to minus 3. Goodness, that stinks. I can't even... Okay, that's a little clearer. I don't know if I got the same thing they did. Let's see. 4x minus 3y plus 5z is equal to minus 3. Goodness. That was way harder than it needed to be. Now, here's another linear algebra application. According to Kepler's law of planetary motion, the orbits of planets are ellipses with the sun at one focus of the ellipse. The general equation of a conic section such an ellipse is, and they give it to you here, and to determine the equation of the orbit of a planet, an astronomer can find the coordinates of the planet along with the orbit of 5 other different points. So as you look and see that, that's going to turn into a pretty hairy looking matrix. But the technology is there for computer algebra systems, graphing calculators. They will all do that kind of stuff. That does finally finish 3.4. Homework exercises are any of the odds 1 through 7. They're all at Calc Chat. Number 9's a proof, should be at Calc Chat. Number 11's a proof, it should be at Calc Chat. 13's a problem, you can do it Calc Chat. 15's a proof, you can check it Calc Chat. Any of the odds 17 to 29, they should all be at Calc Chat. 31 and or 33 should be at Calc Chat. 35 should be at Calc Chat. The ones we did today start with 37 and 39. They should be at Calc Chat. 41 and 43 should be at Calc Chat. 45 and 47 should be at Calc Chat. 49 and 51 should be at Calc Chat. 53 and 55 should be at Calc Chat. And 57 and 59 should be at Calc Chat. Goodness, I'm having trouble. 61 should be at Calc Chat. And 63 should be at Calc Chat. So, do any of those you want. If you need a few more exercises, you do. The review exercises, any of the odds, 1 through 17 should be at Calc Chat. 19 or 21 should be at Calc Chat. This is on pages 138 and 139. 23 should be at Calc Chat. 25 should be at Calc Chat. 27 should be at Calc Chat. Either 29 or 31 should be at Calc Chat. 33 or 35 should be at Calc Chat. Any of the ayes 37 to 41 should be at Calc Chat. 43 should be at Calc Chat. 45 is a proof. It should be at Calc Chat. 47 should be at Calc Chat. 49 and 51 should be at Calc Chat. 53 is a writing, and so it's 55. They should have something at Calc Chat. I don't know what. 57 should be at Calc Chat. 59 or 61 at Calc Chat. 63 at Calc Chat. 65 at Calc Chat. 67, 69, 71, and then some true false, 73 and or 75. And if you wanted a project to do, there's stochastic matrices. We didn't do that. The Cayley-Hamilton theorem, if you want to look at that, you certainly could. I'm not going to require it. There's a 1 through 3 cumulative test. I don't know why they have. No, I guess, yeah. You can look at any of that if you'd like. Where we'll start next time, ending a little early today, is at chapter 4, vector spaces. Any questions? And you got your test, chapter 3 already, right? Okay. And I'm sorry, I can't hear.
When is the second test due again?
Second, well, anytime you can get it to me. I usually like to have it for the third test to give an out, but I've already given out the third test, but it's okay.
I had it finished for a while, but I kept forgetting to go over it and check it.
Right.
I'm gonna check it this weekend. And then I'll take it Tuesday.
Okay, I can't hear, sorry.
So us now, I'm gonna check my answers this
Right.
weekend, and then I'll take it
Tuesday.
Tuesday.
Okay, that would be great. Because even though Monday's a holiday, we have class on Tuesday. Good deal. All right. All right, I'll shut this down.